So if you start with this formula that we just used, and you multiply both sides by the magnitude of u, magnitude of v, you get this right here. Right? These two multiply up here. That's this. All right. Now, if u dot v equals 0, let's just say, right, then that means that one of these, either the magnitude of u, the magnitude of v, or the cosine of theta has to equal 0. Right? Is it possible for a non-zero vector to have a magnitude of 0? No, it can't. So there's no way that you're going to get a product of 0 because one of these two is 0. If this product is 0, it's because the cosine of theta equals 0. Right? So if the dot product is 0, that means the cosine of theta, equals 0. Okay, well, we know what angle the cosine equals 0 at. Think of unit circle. Where is cosine equal to 0? Say again? At 90 degrees, right? So that means theta equals 90 degrees. So if the dot product of two vectors is 0, that tells you the vectors are 90 degrees to each other. When two vectors are 90 degrees to each other, that is called orthogonal, right? You may think of it like perpendicular. It's the same deal. It's just that, remember, vectors don't have a position, right? They're not actually, crossing each other at 90 degrees. That's what two lines do when they're perpendicular. These don't have a position, but they are going in directions which are 90 degrees from each other. It just got a different word. Right? You're not going to get a problem wrong because you said perpendicular and it should have been orthogonal. But you should recognize the word because they are going to say orthogonal when they're talking about vectors. Right? So, therefore, u and v are quotation marks orthogonal. And that is what that means.